So in class, we will be discussing Chapter 2.8, Operations on Functions. Our objectives in this section is to perform operations on functions, evaluate difference quotients, and the third objective is to compose and decompose functions. Our first objective is to look at operations on functions. So the sum of a function f plus g of x is nothing more than the function f of x plus g of x. The difference f minus g of x is equal to f of x minus g of x. The product f times g of x is equal to f of x times g of x. Sometimes we represent this also as fg of x. So either notation will work. The quotient is just f divided by g of x is equal to f of x divided by g of x, provided that g of x does not equal 0. So in our first slide, for examples 1 through 4, we're only going to look at f of x and g of x. So given f of x is equal to x squared minus 3x plus 1, and g of x is equal to the square root of 8 minus x, evaluate the functions if possible. So now we're just going to put in a minus 3 for number 1. We're just going to put a minus 3 in for f of x. And when we do that, we actually end up getting minus 3 squared minus 3 times a minus 3 plus 1. Well, this is just 9 plus 9 plus 1. That's just equal to 19. So now I want you to try number 2. You will pause the video and you will try g of 4. So for g of 4, we have the square root of 8 minus 4, which is the square root of 4, which is just 2. So now I want to try number 3. Why don't you try number 3 for f of x, where f now is going to be evaluated at a plus 1. So we start off with the evaluation a plus 1 squared minus 3a plus 1 plus 1. And now we will expand the square term, so we get a squared plus 2a plus 1 minus 3a minus 3 plus 1. And now we can combine terms and we end up with a squared minus a minus 1. So there's our answer. So now I would like you to also evaluate number 4, pause the video and try g of 10. So this one, you're going to get something entirely different, right? 8 minus 10 is equal to the square root of a minus 2, yuck, right? Which is I times the square root of 2. But this is undefined for real numbers. So we have the same functions as in the previous example, and now we want you to evaluate some of the operations. So number 5, we have f minus g of minus 8. So what we're going to do is we can do f of a minus 8, and when we do that we get minus 8 squared minus 3 times minus 8 plus 1. And when we evaluate that, we get 89. And now we're going to evaluate g of minus 8. Here, let me do this right. We'll do g of minus 8. And in this case, we get the square root of minus 8. Oops, sorry. We do get a minus 8 at some point, but we get 8 minus a minus 8, which equals the square root of 16, which is equal to 4. Now when we do f minus g of minus 8, we just get 89 minus 4, which is just equal to 85. So there's our answer. So now I would like you to try number 6. This is an operation. So we have to be very careful here, right? Or do we? So I'd like you to try this one. I would pause the video and then we will go through it. So the answer you should have received is 4 square root of 2. Did you get that answer? If not, we will go through it. Right? So we have g times h. So when we do this, we have g of x times h of x. And when we do that, we get the square root of 8 minus x times 2 over x plus 1. And so that's just equal to 2 times the square root of 8 minus x over x plus 1. And now that's just equal to, when we put in 0, right? So now we have gh of 0. We just get 2 times the square root of 8 over 1, which is 4 square root of 2. Alright, so number 7, you can evaluate that pretty quickly, right? For this particular one, we just get 2 over a minus 1 plus 1. Ooh, 2 over 0. This is undefined, right? So in example 9, we want to evaluate and write the domain in interval notation. So we're going to look at the first function, and then I'm going to add a function onto this. So these are the 3 functions we're working with, and the function we're working with that we're going to evaluate, actually, and write the domain is r over t of x, right? So r in this case is x squared plus 3, and we're going to divide by x plus 4. Now, do we know the domain? We ask, what are the restrictions on x? Well, x cannot equal 4, and so in interval notation that means I can go from infinity to 4, right? Union 4 to infinity, right? X can be any number but 4, and so that's how the interval notation is written. Now suppose I have a new function. Suppose I'm going to try a function that has s times t. So suppose I have st of x, right? So in this case, what would that function be? Well, I have 2 times x plus 4 divided by x, and then in this particular case this implies that the domain, where's the restriction? X cannot equal 0, so my ending up domain is going to be a negative infinity to 0, union 0 to infinity, right? Our second objective is to look at the difference quotients, and here is nothing more for the difference quotient is like the average rate of change, but with a twist. So the average rate of change between P and Q is the slope of the secant line and is given by the slope, which is m, the change of y over the change of x, which is f x plus h minus f of x divided by x plus h minus x. Now the difference is, normally we have x1 and x2, but you'll notice that x2 has only changed, if you look at the diagram, has only changed by h from x. So now we know that the only difference between x1 and x2 is just h. So now we can just put an h in for the difference. And so that's why we call it a difference function. So this is why the difference quotient. That's why we're going to be using this function here as the difference function, right? And in calculus, to make this even a little bit more apparent, as h becomes 0, in other words, as x2 approaches x1, h becomes closer and closer to 0, and we have what's called the tangent line of the point at x. So we're going to find the difference quotient here for the function 5x minus 2. So we'll just go ahead and do it. The change in y over the change in x is equal to f of 5x minus 2 plus h, right? Well, actually, what we're going to do, I'm sorry, we're not going to do it that way. What we're going to do is we're just going to put it actually into the formula, right? So our first function of this is going to be 5x plus, again I've made a mistake here, 5 times x plus h, right, minus 2, that's our first function, that's f of x plus h, right? And now f of x is nothing more than 5x minus 2, and it's all over h. Well, now we're going to distribute. We get 5x plus 5h minus 5x plus, oops, again, boy, I'm making a bunch of mistakes here, right? We've got to make sure that we get it right. This is a minus 2 still, right? Because that minus 2 we forgot. right? And then we have a minus, when we distribute the negative, 5x plus 2 divided by h. So we got to watch our problems. We got to watch to make sure that we get the details correctly. So now the change in y over the change in x is going to be, notice what happens here. The 5's cancel and the 2's cancel, and I'm left with 5h over 5, which is just 5. So the difference quotient for this function is just 5. Okay, we're going to apply this to this particular problem, example 12. And so again, we're going to use the different quotient idea. And now we're going to put in the first function plus h. So here is where you've got to be careful, right? So this is going to be x plus h squared minus 3x plus h, right, plus 8, and that's the first function. That's this function right here. And now we're going to subtract off just the regular function, which is x squared minus 3x plus 8, and it's all divided by h, right? So now this is nothing more than x squared plus 2xh plus h squared, this gets a little long, right, minus 3x minus 3h plus 8 minus x squared minus 3x plus 8. And this is all over, we got to make sure that we get this right, it's all over h. Pretty long thing, right? So now we have to combine like terms. Well, guess what? The x's cancel. Oh, I made a mistake again, didn't I? This should be a plus, right? And I made another mistake. This should be a minus 8. So see, I'm making mistakes with the negatives. See, the negatives have to apply through, and I got to make sure that I do that right. So the other things that cancel, these should also cancel, by the way, right? And I should be left with 2xh plus h squared minus 3h, right, all over h. And now I can cancel an h from each term, so I get 2x plus h minus 3. And I'm going to just rearrange the terms, so I get 3, or actually I get 2x minus 3 plus h. There's our answer. And if h goes to 0, then we have the tangent line's slope. So now it's your turn. Skill practice 5. I want you to try this particular problem and pause the video. Okay, so let's do part A. So for part A, we just want to find f of x plus h. And so now we just do a minus x plus h squared minus 5 times x plus h plus 2, and that will give us the following. So for part A, we get a negative x squared minus 2xh minus h squared minus 5x minus 5h plus 2. So there it is. And now we're going to do part B, right, which is the change, which is actually the difference quotient, right, f of x plus h minus f of x over h, right? So now we have this very long amount of information, minus x squared minus 2xh minus h squared minus 5x minus 5h plus 2. But now we have the minus of the f of x, and the minus of the f of x is just a plus x squared, because we're going to distribute the negatives, plus 5x minus 2. This is all over h. Now we can do some cancellations. There's a cancellation, there's a cancellation, there's a cancellation. And we're left with a minus 2xh minus h squared minus 5h over h. So we get a minus 2x minus 5 minus h. So there's our final answer. So in this particular objective, we're going to do compositions of functions. The composition of f and g is denoted by f of g, right, of x, right? This is called fog, and is defined by f g of x, right? So that's how we're going to work it, and we call it fog. So given the following equations, x squared minus 3x plus 1, and g of x is 5x plus 4, find the fog f of g of x, right? So now what we're actually asking for is f of g of x, which is 5x plus 4. So now we're just going to insert the 5x plus 4 for wherever the function is for f of x, and we can do that. That's 5x plus 4 squared minus 3 5x plus 4 plus 1. This is 25x squared plus 40x plus 16 minus 15x minus 12 plus 1. This is 25x squared, and then when we take 15 from 40, we get another 25x, and then we get a plus 5 when we add the numbers together. So now I would like you to do just the opposite. I would like you to pause this video and do g of f, which is golf. So we're going to go ahead and try this one, right? So here we're going to go g of x squared minus 3x plus 1. And now this is equal to 5 times x squared minus 3x plus 1. And, this is plus a 4 here because now we're using this function, right? So now we distribute, we get 5x squared minus 15x plus 5 plus 4. That 4 is at the end here. And this is equal to 5x squared minus 15x plus 9. So there's our final result. So again, in example 14, we're also going to do the fog and golf. So the first one is f g of x, right? So here we're going to do f the square root of 5x plus 5. So we put that into the equation. We get 5 times the square root of 5x plus 5 squared minus 1. This is going to be 5 times 5x plus 5 after we square it, minus 1. And this is equal to 25x plus 25 minus 1, 25x plus 24. So there's our final result for this one. Now go ahead and pause and see if you can do golf. So again, we're going to do I'm going to do g of 5x squared minus 1. So we're going to put that into the square root function. So we get g of f of 5x, well, g of x actually, right? We're not evaluating yet. So in this particular case, it's just going to be the square root of 5 times 5x squared minus 1 plus 5. This is equal to the square root of 25x squared minus 5 plus 5. This is equal to the square root of 25x squared, which is equal to 5 absolute value of x. Why the absolute value of x? Because we're taking the square root of x squared. X squared is always going to be positive, so the number x, regardless of whether it's negative or positive, is always going to be a positive in this particular case. So, example 15, now we're going to evaluate functions at particular points, especially composite functions. So now we have fog of 9. So the way we do this is we know it's f g of x evaluated at 9. So we're going to do the first process is do g of 9, and in this case it's going to be 2 times 9 minus 8, and this is what, 18 minus 8, which is 10. So now we're going to evaluate the function at 10, right? And so now we come up here and we get 3 divided by 10 minus 4 is equal to 3 divided by 6, which is equal to 1/2. So there's our answer for fog of 9. Now I'd like you to pause the video and try a golf of 6. So in this problem, you should have gotten, the answer should have been 5. And if you didn't get that answer, we'll show you why. So the first step is, I know I want g of f of 6, right? So I'm going to evaluate f of 6 first. And that's just going to be 3 over 6 minus 4, which is 3/2, right? Now I'm going to evaluate this at g at 3/2, right? Which means that I will put this in for 2 times 3/2 minus 8. This is just 3 minus 8, which equals 5. There's our answer. So we always want to find the domain and ranges of composite functions, and in this case we're going to do that. The first step is to look at f of x. So for f of x, right, the domain has a restriction on -2. So x cannot be a -2. Well, that's not good enough, of course, because now we have to incorporate the composite. We know that x can't be a -2 when we apply the function, and that makes sense. But now, when we do the composite, we get the following. So we look at f g of x in the entirety, and we get 3 divided by 3x minus 2 plus 2, right? So this is 3 divided by 3x, right, which is equal to 1 over x. So this also implies that x cannot equal 0, right? Well, in any case, we now have the domain in different areas. So x can be anything up to a -2, right? But it can be a -2 to 0, because we can't have 0 here. And it can be from 0 to infinity. So there is our domain for this particular case. So in the future of calculus, we usually have to break functions down from a composite to 2 separate functions. And so that's what we're going to do. So we're going to look at the function h of x, and we're going to break it into 2 functions using the composite idea, right? So in this case, we have h of x is equal to a square root function plus some other entity inside that. So we've got a function within the function. So now the idea is, okay, So since we have f g of x, right, now we can look at the inside part of the function of g of x. So let g of x equal 3x minus 7. So that means that f of x has to be the square root of x, right? So does that work? Well, let's see. F g of x is equal to f 3x minus 7, which equals the square root of 3x minus 7, and that's equal to h of x. So it works. So in this example, I want you to find two functions, f and g, such that h of x is equal to the fog of x. And so here the original function is h of x is equal to x plus 1 cubed plus h. So go ahead and pause the function and see if you can get the correct answer. So in this case, we have f g of x, and we know that the composite, this is now the composite function of x plus 1 cubed plus 8. So if we have f of x plus 1, we now have the function g of x cubed plus 8. So now we know that g of x has to equal x plus 1, and f of x is equal to x cubed plus 8. So now we try our luck. We say, okay, suppose we have f of x plus 1. Well, that's going to be x plus 1 cubed plus 8. This equals h of x. So we're done. So our two functions here that we've broken it out into, or the two pieces, is g of x is equal to x plus 1, and f of x is equal to x cubed plus 8. Now we're going to go directly from graphs to estimate the values of function operations. So in this particular case in A, we'll get to the graph in just a second, but we're going to do the algebra first. We get f of 3 minus f of, of g of 3, right? Minus g of 3. And now we go to the function itself. We say, okay, where is f of 3? So we come over 3 and we go up to here and we say, oh, it's 4, right? So this is equal to 4. And g of 3 is, if we come over to 3 and we come here, oh, it's 3. So it's 4 minus 3 is equal to 1. Not a bad deal, right? So now in part B, we're going to do the same thing. We're going to evaluate g of minus 2 over f of minus 2. And now we go to the graph and we say, oh, where is g minus 2? G minus 2 is right here. And we see it is 1, 2, 3, 4. It's at a minus 4. And for f of 2, we come over and we see that it is at 2. So this is equal to a minus 2. So now I'd like you to try this. We have a composite function g of f of 1. So go ahead and try that particular one and see what you get. So in this case, you should have gotten 4. And you say, well, how is that possible? So the first step is f of 1, right? We look at f of 1 and we say, oh, f of 1 is 2. And now we're going to do g of f of 1, which is 2. So we look at g of 2 and we see, oh, it's 1, 2, 3, 4, right? So what we did here is we did g of f of 1, right? So we first found f of 1, we put it in here, and then we could evaluate it over here at 2. Go ahead and pause the video again and try fog of -3. So here you should have gotten the answer to be a -2. And so here again we're going to do f of g of -3. So we have to do g of -3 first. So when we do a -3, we come over and we say 1, 2, 3. G of -3 is what? Well, it's 4. It's a -4, right? So now I'm going to do f of a -4, and that's equal to, when I come over here, oh, I see it's a -2. So the last problem is f of not -3, so I'd like you to pause and try that one. So here you should have gotten a 2. So again, f of a -3 is equal to f of, so f of -3, 1, 2, 3 is 0. So now I'm evaluating this at 0, and now at 0 I see f is there, right? So f is at 2. So I have my slides misarranged. I don't know how that happened exactly, but in this particular problem, the next slide is going to show you part A and the actual problem. And the actual problem is a party balloon is being filled with helium. As a balloon is filling, the radius of the balloon is changing at a rate of 3 inches per second. So part A asks to write r of t, the rate, in a time element. So in part A we end up having the radius t is equal to 3t. So for each second the balloon is increasing by 3 inches. So in part B it says write a function that expresses the volume of the balloon v of r as a function of its radius. So in this particular case, the volume of a sphere well, I didn't spell that correctly. no, of a sphere. I'm going to leave that alone right at the moment. So the volume of a sphere is nothing more than the following. It's 4/3 pi r cubed, right? So that's the volume of a sphere. And so now I want to write v of t, v of r actually, in terms of this. And we're going to get 4/3 pi times 3t, and this is going to be cubed. And when we do this, we're going to get 36 pi t cubed. So this is the volume of the cube in relationship to time. Originally it's going to be actually v of r is just equal to 4/3 pi r cubed, and then we're going to write it that way. So we're writing it that way in part C, right? So we go from the volume of a sphere, right, to the writing it in terms of the composite function, right? There's a composite function here. The composite function is made up of two functions, v of r and r of t. So in this case, v function, the composite function of v of r of t is just equal to 36 pi t cubed. This was the original problem, and we found out that r of t is just equal to 3t. And now we want to evaluate the composite function at 2 and interpret the meaning for that. So what we do is we put in the value v of r of 2, right? And in this case, it's going to be 36 pi 2 cubed, right? And when we do the problem, we end up with, what do we end up with? Somewhere. Oh yeah. This is equal to 288 pi, which is approximately 904.32 cubic inches. So after 2 seconds, the balloon volume is approximately 904.32 cubic inches. Okay, so that concludes our chapter 2.8. Please study some of the problems in the lecture problems in the class prep section, and also look at some additional problems in this section and do the assignment.